Retrograde motion is the apparent motion of a planet to move in a direction opposite to that of other bodies within its system, as observed from a particular vantage point. Direct motion or prograde motion is motion in the same direction as other bodies. While the terms direct and prograde are equivalent in this context, the former is the traditional term in astronomy. The earliest recorded use of prograde was in the early 18th century, although the term is now less common. Etymology: the term retrograde is from the Latin word retrogradus, a backward step, the affix retro meaning backwards, and gradi to step or to go. Retrograde is most commonly an adjective used to describe the path of a planet as it travels through the night sky, with respect to the zodiac, stars, and other bodies of the celestial canopy. In this context, the term refers to planets, as they appear from Earth, to stop briefly and reverse direction at certain times, though in reality, of course, we now understand that they perpetually orbit in the same uniform direction. Mercury in retrograde is an example of the term used as a noun for retrograde motion. Retrograde is also sometimes used as an intransitive verb meaning to become, to appear, to behave or appear to move in a retrograde fashion. Although planets can sometimes be mistaken for stars as one observes the night sky, the planets actually change position from night to night in relation to the stars. Retrograde and prograde are observed as though the stars revolve around the Earth. Ancient Greek astronomer Ptolemy in 150 AD believed that the Earth was the center of the solar system, but still used the terms retrograde and prograde to describe the movement of the planets in relation to the stars. Although it is known today that the planets revolve around the Sun, the same terms continue to be used in order to describe the movement of the planets in relation to the stars as they are observed from Earth. Like the Sun, the planets appear to rise in the east and set in the west. When a planet travels eastward in relation to the stars, it is called prograde. When the planet travels westward in relation to the stars, it is called retrograde. Apparent motion. From Earth, when we observe the sky, the Sun, Moon, and stars appear to move from east to west because of the rotation of Earth. However, orbiters such as the Space Shuttle and many artificial satellites appear to move from west to east. These are direct satellites, but they orbit Earth faster than Earth itself rotates, and so appear to move in the opposite direction of the Moon. Mars has a natural satellite Phobos, with a similar orbit. From the surface of Mars it appears to move in the opposite direction because its orbital period is less than a Martian day. There are also smaller numbers of truly retrograde artificial satellites orbiting Earth which counterintuitively appear to move westward, in the same direction as the Moon. As seen from Earth, all the other planets, asteroids and all objects in our solar system appear to periodically switch direction as they cross the sky. Though all stars and planets appear to move from east to west on a nightly basis in response to the rotation of Earth, the outer planets generally drift slowly eastward relative to the stars. Asteroids and Kuiper belt objects exhibit apparent retrogradation. This motion is normal for the planets, and so is considered direct motion. However, since Earth completes its orbit in a shorter period of time than the planets outside its orbit, it periodically overtakes them, like a faster car on a multi-lane highway. When this occurs, the planet being passed will first appear to stop its eastward drift, and then drift back toward the west. Then, as Earth swings past the planet in its orbit, it appears to resume its normal motion west to east. Inner planets Venus and Mercury appear to move in retrograde in a similar mechanism, but as they can never be in opposition to the Sun as seen from Earth, their retrograde cycles are tied to their inferior conjunctions with the Sun, and are thus unobservable in the Sun's glare and because the planets are in their new phase, with mostly their dark sides toward Earth. They occur in the transition from morning star to evening star. The more distant planets retrograde more frequently, as they don't move as far in their orbits while Earth completes an orbit itself. The center of the retrograde motion occurs when the body is exactly opposite the Sun, and therefore high in the ecliptic at local midnight. The retrogradation of a hypothetical extremely distant planet would take place during a half-year, with the planet's apparent yearly motion being reduced to a parallax ellipse. The period between the center of such retrogradations is the synodic period of the planet. This apparent retrogradation puzzled ancient astronomers, and was one reason they named these bodies planets in the first place. Planet comes from the Greek word for wanderer. In the geocentric model of the solar system proposed by Apollonius in the 3rd century BCE, retrograde motion was explained by having the planets travel in deferents and epicycles. It was not understood to be an illusion until the time of Copernicus, although the Greek astronomer Aristarchus in 240 BCE proposed a heliocentric model for the solar system. Interestingly, Galileo's drawings show that he first observed Neptune on December 28, 1612, and again on January 27, 1613. On both occasions, Galileo mistook Neptune for a fixed star when it appeared very close in conjunction to Jupiter in the night sky, hence, he is not credited with Neptune's discovery. During the period of his first observation in December 1612, Neptune was stationary in the sky because it had just turned retrograde that very day. Since Neptune was only beginning its yearly retrograde cycle, the motion of the planet was far too slight to be detected with Galileo's small telescope. From Mercury, at certain points on Mercury's surface, an observer would be able to see the sun rise partway, then reverse and set before rising again, all within the same Mercurian day. This apparent retrograde motion of the Sun occurs because, from approximately 4 Earth days before perihelion until approximately 4 Earth days after it, Mercury's angular orbital speed exceeds its angular rotational velocity. Mercury's elliptical orbit is farther from circular than that of any other planet in our solar system, resulting in a substantially higher orbital speed near perihelion. See also, retrograde and prograde motion, Hipparchus, Ptolemy, Shen-Kuo, Spherical Astronomy, Hui-Pu, References. External links, composite photograph of the 2009/2010 retrograde motion of Mars, animated explanation of the mechanics of a retrograde orbit of a planet, University of South Wales, NASA, Mars retrograde motion.